It's biology with Mr. B. Biology with Mr. B. That's me! Hello, Year 11 again. I hope the lesson yesterday went okay going through the exam. If it didn't, or you missed bits, please drop us an email. Okay, I can send that link to that video back if needs be. So, today is your first lesson of nearly the very last topic, biodiversity. And the focus of today is to look at the human population problem. So what is wrong with having 7 odd billion humans on the planet compared to half that 100, 200 years ago? I need you at the end of the day to know a definition for the key term biodiversity. I need you at the end of the day to be able to explain to others why it's a good thing for an ecosystem to have a high biodiversity. And I need you, this is my big concept, to be able to link the rapidly growing human population we have to that effect on pollution levels and therefore its effect on biodiversity. Because we can absolutely link pollution and biodiversity together, and we're going to do that quite often during this topic. Now, little word to the wise. The biodiversity topic is, we leave it to last because it's supposed to be really easy. And in contrast to what we've been doing over the last few topics, in particular like the inheritance work, you might remember all the kidney and the eye and stuff from paper 2. Yeah, biodiversity is easy in comparison. It's not full of all these like massive processes you've got to go away and learn. The problem we've got is it comes up a lot. And if your language isn't perfect, if you are not delivering the spec point to the examiner almost word for word, you do not get full credit. So as we're going through this, I need you constantly to be looking back at these spec points and making sure that not only are you confident with the ideas, but you're confident describing those ideas using the right terminology. So, today, first thing I'd like you to do is try and think in your pairs what the word biodiversity actually means. You got 60 seconds. If the cover teacher, whoever you are, lovely human being, if you can pause me for a sec and give them 6 seconds to think and then press play when they've had a good time thinking and talking to each other about what that could be. So, bio. Anything with bio in means living. Bio, biological organisms, living things. Diversity, the amount of variation. So if you are very biodiverse, that would imply there's a lot of variation between living things. If you're not very biodiverse, it implies, well, maybe you've got a farm and all they're growing is wheat, something we call a monoculture. Your definition. Biodiversity is the variety of all the different species of organisms in an ecosystem or in the world. The variety of all the different species of organisms. So that's your first learning point, done. Second point, why do we actually care about having a high biodiversity? Why does it matter to us? It matters because if we didn't, we'd be dead. There you go, that's shock factor for you. We've been in the topic of energy flows, we've dealt a lot with food chains, and we pretty much always drew them like this, like a single food chain. But the reality is, in an ecosystem, you don't have ecosystems which are only one chain long. Ecosystems usually show food webs, where there's several different producers, and lots of different primary consumers, lots of different second consumers, and then still you might only have 1 or 2 of those apex predators at the top. Now what we're actually doing here is, imagine you've just got a single food chain like this one on the left, and a brand new disease comes in and wipes out the little squeaky mouse. Well, that means the owl dies as well, because the owl loses its only food source. I mean, happy days if you were cricket-like, no one's eating you, but you've lost half the food chain. God forbid a new disease came in and wiped out the grass. Then the entire ecosystem fails. But in this example, if we had a new disease and it wipes out the squeaky mouse, well, if you're an owl, not a problem. You can still eat the bunny rabbits. You can still eat the squirrels. You can still eat the birds. So your survival isn't necessarily in doubt. Will it affect you? Yeah. Will some individuals maybe not have enough food to survive and reproduce? Of course. Will it increase competition amongst the owls because there's less food demand? Of course. But will the owls die? Will they go extinct from that particular ecosystem? No. So this is the crucial bit. This chain here, because I've only got one food chain, one species of each trophic level, that chain has low biodiversity. And as a result, they are completely dependent on one another. If something happens to one organism, they are all significantly affected. On the right-hand side, my food web shows high biodiversity. They're not as dependent on each other for food and for shelter. If something happens to one, all right, of course it will have an effect. But are they all going to be significantly affected? No, they're not. Again, you may want to pause it right here so that students get an opportunity to make a little bit of notes if they are making notes as they go. So, the big problem in the world with biodiversity is that it's getting less. And the reason is you, especially James Trevor, but all of us. So we now have to look at the human population explosion that has been over the last few years. And we need to link the idea of a higher population to humans affecting the levels of biodiversity. So I need you now to have a go at task 1 in your booklets, but not all of task 1. I do not need you, just get my pen. I do not need you to do question 2. Oh, wow, that is embarrassingly poor pen control. What I do want you to do, I do want you to do question 1, which is another good opportunity to be able to do a bit of graph practice, and I do want the questions that follow question 3. So I'm going to pop these now. Oh, again, can I end it? Discard. I'm going to pop this on here. So just to clarify, I do want question 1 done. I don't need any of that bit done. So I do want question 1, and I do want these questions that follow, and they follow across the page here as well. The extension is this follow-up if anyone finishes particularly quickly. You've got 15 minutes, please. So please pause me, and in 15 minutes, you can put me back on again. Thanks very much. Okie dokie. What I need from all of you guys is we're going to peer assess our graphs, so I need you to swap your graphs with someone else. Make sure you have access to a green and access to a blue pen. Right, I'm ready to go, so I'm going for it. Here's what I'm after. Give them a big fat tick if on their x-axis they put the independent variable, which in this case would be years, and I doubted myself what the unit would be. I've put AD because I guess the years that they've used are specific to the Christian calendar, aren't they? And again, I might be getting that completely and utterly wrong, but I've put AD might be a unit. If you have just put years, I generally think that is okay in this context. On the y-axis, flying high, we should have the dependent variable, so what was measured? What was measured was the actual population. In units would be in millions. I shouldn't have to do this, but I'm going to sing. There is a verse or the variable song which tells you where these variables go. Are you ready to join in? Independent variable goes on the x-axis. Independent variable goes on the x-axis. Dependent one flies high on the axis known as y. Independent variable goes on the x-axis. You're welcome. Please give them absolutely big tick if the scales on both those axes are increasing and increasing evenly. Please give them a big tick if the plots they have drawn are x's, not dots, x's. And they must be accurately drawn. If they are a single square, a single millimetre out of where they should be, then they are wrong. We should have a line of best fit that shows the trend of those results. And I'm gonna show you what that hopefully looks like in a sec. And it should have a title that tells you what the graph is showing. The title, by the way, should include both independent and dependent variable in it. So a nice example could be a graph to show how the population of the UK changed from 1200 to 2000 AD. Well, I just want to show you very quickly what I actually would expect that graph to look like, in particular the line of best fit. So the human population was rising very, very steadily. It then dropped randomly, and they continued to rise, and got very, very rapid towards the year 2000. If anyone has drawn dot-to-dot dinosaurs, so literally just drawn dot-to-dot the X's, no, please don't ever do that. What I really need from you is a smooth curve all the way up, potentially circling this X here as an anomaly, the one where it decreases.
We were coming to sing the variables song.
Oh, wow. Cassie, do you want to come say hi?
Come on, come say hello.
Come say hello.
Hello.
Okay, say nice and loud. Hello.
Hello.
Can they see you?
No, they can't see us. I'm not going to put that on. Cassie is saying hello to everyone. And that cough is the reason why I'm stuck at home. So lovely. Thank you very much.
Independent variables, the one you... He said change.
Change.
Independent variables, the one you...
Feel free to fast forward this bit.
Change.
Dependent one you measure, get it wrong, you feel displeasure. Independent variables, the one you...
Down.
For God's sake.
Change. Bye, sorry.
Yeah, I hope you fast forwarded that bit. Either way, that's what I'd like your line best fit to look at. So, in terms of doing your what were Well's even better ifs, please, all in a green pen. I want nothing other than in green. Please give me what well that's actually about the science. If you do anything like this, what well here, I like it's in a pink. No, just bad people. An EBI, again, a good one will be about the science, about these points. A negative one would be anything to do with neatness or tidiness. Just no, get away from it. Okay, you're welcome to pause me while students do that. Either way. Okie doke, so I'm now moving on to the answers to those questions. Let's get this on the big screen. And get my remarkable up as well. Okie dokie. So, describe the trend in human populations over the last 800 years. The trend I should be looking for here is that, number one, you should have an idea that there was a steady increase until about 1850 or 1900. That's your first mark. The second mark is that thereafter there is a rapid increase from 1900. Now this is a describe question. If you're to describe any sort of data, you must use it in order to claim those marks. So a steady increase until about 1900, okay, but how much has it increased by? It started at 2 and it ended at 25. So in a 700-year period, there's been an increase of 23 million. The rapid increase from 1900, again, in a 100-year period, we've got an increase of 35 million. So in the last 100 years, there's been more population growth than the 700 years prior, which is big. For question 2, the sort of factors which human populations have affected. Maybe as a factor you went for air. And you talked about air pollutants like carbon dioxide released from burning fossil fuels. Maybe sulfur dioxide, which obviously contributes towards acid rain. Maybe even smog, which causes respiratory problems. Smog, by the way, is my new favourite word. Love it. Maybe the factor you went for was water. Water pollution. Maybe, the classic thing nowadays is all all things plastic. But maybe you also talked about sewage. I'd be very, very impressed if anyone talked about eutrophication. Eutrophication is going to be the focus of one of your lessons next week. Eutrophication is where a farmer's fertiliser, which contains things like nitrates and magnesium, things that help plants to grow, if some of that fertiliser gets into water, it will kill all the fish. Now, that might not make much sense, because fertiliser is, minerals that plants, help plants grow. Surely if plants are growing, that's only a benefit for fish, but actually the opposite. And we'll explain that next lesson. Another factor you could have gone for was land. Think like industrial waste, so like landfills, dumps. Industrial waste can be toxic, and that's polluting the soil. Sewage as well, obviously it doesn't have to go into rivers, it could also go into the soil. Maybe you also talked about deforestation. Trees are amazing when it comes to pollution because they absorb all the carbon dioxide. Obviously not all the carbon dioxide, but they absorb a fair bit in order to do photosynthesis. So chop the trees down, therefore means there's more carbon dioxide in the atmosphere, leading to more global warming, leading to more polar ice caps melting, meaning leading to more polar bears swimming for their life. Yay! Maybe, I don't know if anyone went for this, but you could have gone for natural resources. So linking it more to the chemistry ideas around mining. And again, if you're quarrying and if you're mining, you're using huge amounts of land, aren't you? Land that could have been used to grow plants and animals. To grow plants and therefore provide a habitat for animals. Question 3. Why families typically had more children before 1900 than they do now? It was because of high infant mortality rates. More children died before 1900 than they do nowadays. Because more children died, parents would therefore have more children in the understanding and the knowing that not all of them would survive to adulthood. And I'm sure you appreciate before the 1900s there weren't exactly pensions, so any individual who got to old age and maybe couldn't work, they would rely on their children to look after them. Question 4. What needs to happen for the birth rates and death rates for a population to remain fairly constant? Ooh. God, I can't write. They need to be equal. You need the birth rate and death rate to be equal for a population to remain fairly constant. So for every 10 that are born, 10 die. Question 5. Suggest a reason why it would be better for the environment if the human population stopped increasing or even decreased slightly over time. Again, in the current climate of coronavirus, maybe not the right question to ask. But any reasonable suggestion, so maybe if there's less people, we're going to use less resources, therefore make less pollution. We're going to burn less fossil fuels because we're going to need less energy. We're going to it's going to mean that less plastic is going to go to our oceans. Key idea is there's going to be less pollution. Now let's make the link. If there is pollution, it means more animals and plants will die. If more animals and plants die, what does that do to biodiversity? More death leads to a lower biodiversity. So if you increase pollution, you increase the death rate and you lower the biodiversity. If we decrease pollution, we decrease the death rate which will lead to a higher biodiversity. So how do we create these high biodiversities with these amazing ecosystems full of lovely interdependence where organisms aren't just reliant on one other organism for shelter or for food? How do we do that? We stop polluting. We protect ecosystems from human pollution, from human waste. If we can do that, we'll get biodiversity back again. Okie doke. So in terms of where I'm at the minute, I'm hopeful that in terms of time-wise of the lesson, that you probably have another 20 minutes-ish left. If it's less than 20 minutes, please don't pause me from this point. Please just let this video go all the way to the end. If you have got 20 minutes, then you've got time to finish this lesson. So I'd like to look at task 2 now, please. Task 2, there is just a nice little table with a few diagrams and a few boxes. Every single answer, every single box needs that red answer written. I don't need you to write it in every box. If you just write it at the top, just appreciate that every box has this idea. Doesn't matter whether you're quarrying, whether you're building. If it's affecting land, that means there is less land available for other animals and in particular other plants to live. And therefore there's less biodiversity in that area. Because the plants and animals have got nowhere to live. Plants won't grow, therefore animals won't be there because prime consumers have nothing to consume. So by doing any of these activities, we are reducing biodiversity of that area. If you have got time in the lesson, so 20 minutes-ish, what I'd like you to now try and do is, what other things are going on in those processes that are contributing to lowering the biodiversity of the area? So in terms of land, yeah, they're reducing the land, therefore less biodiversity because plants aren't growing. But what else is happening in those factors, in those things like farming, quarrying? What else is going on that might maybe increase pollution and therefore lower biodiversity? Now's time to pause if you have time to do that task. If you don't, let's keep going and I'll go through. Building. So of course, the more houses, shops, roads, etc., the less plants can grow, less animals can grow, less biodiversity. But what else? Maybe you acknowledged that that house is made of wood. Where have they got the wood from? They've chopped down trees. That's deforestation. Deforestation obviously means there's now less of a habitat for other plant animals to live in. Therefore lower biodiversity where those trees originally were from as well. Not only that, less trees there are, the less carbon dioxide absorbed from the atmosphere for photosynthesis, which increases CO2 levels in the atmosphere, increases global warming, increases pollution levels, increases death of plants and animals, and therefore lowers biodiversity. Quarrying. So even in that picture, look at all those vehicles transporting all the ores that they've just quarried. Well, they all run on fossil fuels, don't they? Petrol. I don't reckon any of those diggers are electric yet. Well, even if they are electric, where did you get that from? Burning fossil fuels. So certainly transport of anything is also obviously going to contribute towards pollution levels, carbon dioxide levels in the atmosphere by burning those fossil fuels. Farming. So again, you might have got the idea of a agricultural bit of transport. So in terms of burning fossil fuels from that motor. But also, by growing that farm, we're making sure that there is what we call a monoculture. So there's only one species growing. So any natural species, that's natural plants and natural animals, are also destroyed from that area. That ain't very good. Last one. Oh, come on. There we go. Dumping. Dumping waste pollutes the environment because some of that waste will be toxic. And also, simply by having a landfill, in that landfill, how are the plants going to grow? They're not. If the plants can't grow, you're going to significantly affect the type of animals that are going to be there as well, reducing that biodiversity. If you did get any other really nice examples of how pollution, biodiversity might be lowered, so other types of pollution, please share them across the class. So maybe pause me now and give an opportunity for students to do that if they got any extras. Key thing is, if it increases pollution, it decreases biodiversity. Okie doke. I am now towards the end of this lesson. The only thing I'd like to talk about at the end was this extension. I appreciate you might not have had time to go into it, but this is actually a really, really important idea. Describe 2 reasons why humans are using more resources and therefore creating more waste and more land pollution. What's happening here, guys, because the population is increasing relatively exponentially, there's more humans around. And because there's more humans, we're using more resources and we're creating more waste. The second reason human beings around the world have an increasing standard of living. Even from when I was a kid in the 90s, the standard of living now is far higher than then. When I was your age, ketchup was deemed a luxury and we only got it on special occasions. The standard of living has increased. Compare it to 100 years ago and think how much the standard of living has increased. If you look at maybe sort of developing countries, so third world, who are maybe now what we call second world countries and starting to develop, their standard of living of the last 30, 40 years has been massively increased. For the first time, there are communities that have electricity, have energy, have power. And because there's more in places which basically now need that energy to keep that standard of living, well, as a result, they're going to be creating more waste from it. More plastic packaging, etc. So, the reason why I'm ending with this bit is because I've seen this come up a couple different times in exams over the past few years. Once in this new spec, but also it used to come up all the time in the old spec. Always 2 reasons why humans are using more resources and creating more waste. 1, there's more of us. 2, we have a better standard of living. This is the one that everyone forgets in the exam. So make sure that's not you. Right, that's the end of my lesson for 11 set 3 on the first one of biodiversity. Thank you very much for listening. That's Mr. Bateson. Peace out. Nice one. Bye.